We're going to look at some more problems with solving systems of linear equation with graphings, but what I call trick problems. So to start with, it'll look just like any other problem. It'll say solve by graphing. And remember, when you solve by graphing, there's 3 steps. Graph line number 1, graph line number 2, see where they cross. So solve by graphing, you have y is equal to 4x plus 3. And 20x minus 5y is equal to minus 15. I'm going to graph these two. This one I'm going to leave the way it is. Y is equal to 4x plus 3. It's easy enough to graph. And the second one I'm going to rewrite it so it's y equals mx plus b. So that's 20x minus 5y minus 15. I'm going to subtract 20x from both sides. And I get minus 5y is equal to minus 20x minus 15. I'm going to divide by a minus 5 and a minus 5 and a minus 5. And I get y is equal to, that's going to be a positive 4x. This is a negative divided by a negative. A negative divided by a negative will be a positive, and it's going to be a positive 3. So I'm going to graph these two lines. Y is equal to 4x plus 3. Y is equal to 4x plus 3. We can stop right there. The y-intercept of both of these are 0, 3, and the slope for both of them is 4, so they're actually the same line. 1, 2, 3, up 4 and over 1. There's line number 1. There's line number 2. They're on top of each other. These are called coincident lines. Coincident lines. And the answer is all real solutions, or these are identities. Since they're identities, I'm sorry, I missed about, they're not all real solutions, they're identities, which means there's an infinite number of solutions. So if someone asks you to solve this by graphing, you're going to say there's an infinite number of solutions. And that's your final answer there. That's what I mean by trick. You could still graph these. If you graph these two, you get 2 lines on top of each other, and where they intersect everywhere along that line. Let's do another example. So let's go minus 2x plus y is equal to 3. And let's go 4x minus 2y is equal to minus 12. So I'm going to graph the first line and the second line. I'm going to do that by rewriting y equals mx plus b. So that's minus 2x plus y is 3. I'm going to add 2x to both sides, and I get y is equal to 2x plus 3. Y is equal to 2x plus 3. The y-intercept is 0, 3. And the slope is 2, or 2 over 1. Let's rewrite the second problem. 4x minus 2y is minus 12. And I'm going to subtract 4x from both sides, and I get minus 2y is equal to minus 4x minus 12. And then I'm going to divide by a negative 2, and I get y is equal to a negative divided by a negative is a positive, so that's a positive 2x. Negative divided by negative is positive again, and then positive 2x plus 6. So in this one, the y-intercept is 0, 6, and the slope is 2 over 1. Now if you notice here, these two lines, they have the same slopes, but they have different y-intercepts. If you have the same slope, well, let's just write that down. You have, and then we'll graph it to see what it actually looks like. So here you have y is equal to 2x plus 3. Y is equal to 2x plus 6, right? So if you have same slope and different y-intercepts, that means that you have parallel lines. And if you have parallel lines, then there are no solutions. And we can see that easy enough by simply graphing this. So here we have 2x plus 3, so the y-intercept is 3. And the slope is up to and over 1. Up to and over 1. Let's draw this in. And then the next one is y-intercept of 6. 1, 2, 3, 4, 5, 6. Again, up to and over 1, up to and over 1. Now, when you graph this, they'll look like they're parallel, but you won't be able to exactly tell. In fact, I didn't draw it all that well there. More like that, right? These look like they're parallel lines, so that's the reason it's good to know the rules. The rules are that if they're the same slope and different y-intercept, that means they're parallel lines, and if there's parallel lines, it means there's no solution. So that's what I mean by trick problems for solving system and linear equations by graphing. If they have the same slope, here's the rule. Same slope, same y-intercept. That means they're the same line, which means there's an infinite solutions. There's an infinite number of solutions. If they're the same slope, but they're different y-intercepts, that means they're parallel lines. And if they're parallel lines, that means there are no solutions. And that's how you solve these problems.